Okay. Okay.
Well, good morning, everyone. Hope you all are doing well. I've really enjoyed going through everyone's introductions, so thank you all for introducing yourselves. Before we really get into everything, I guess I need to say that I was just looking this morning, and I mentioned I was going to put up a little quiz kind of from the syllabus and the VDAX brochure, and I just noticed this morning that it didn't save. So I will have to redo that, but otherwise I think we're on task. I'm going to go ahead and get into chapter 1 here, and it's kind of a jumping all over the place chapter. We're going to go kind of quickly through it because it is, at least the first part, because it is, 10,000 plus years of history and, less than an hour. So bear with me as we go through this quickly. And if you wouldn't mind, if you have any questions, just go ahead and some notes, and then just hold your questions for the end as we get through it, or possibly for Wednesday, depending on how quickly we can get through this. I don't mean to rush through this history, but it's just a lot to cover in one class period. So let me go ahead and shift to that. Oh, actually, it looks like you might need to make me a co-host there, Tom.
Oh, yes, I'm sorry. I forgot about that.
Quite all right.
Okay, now give it away.
All righty, here we go.
And the Alberta people are locked out. I'm trying to get somebody to unlock the door for them.
Oh, goodness.
Yes. That's the problem with all this COVID stuff, and where we open up a new building on that campus, there's not many people in that building. So it's a matter of finding somebody that might be in it.
For some reason, I don't think it's showing the right screen here. Let's see if I can switch.
We're seeing like the slide, and then the next slide over on the right with the notes page.
That's not what I wanted to show. Let's see. Looks like Albert is making it in. Welcome, everyone.
Allison, who let y'all in while we're trying to get stuff going?
I'm not really sure.
Okay. Fair enough. Okay, you right now, Ben.
Okay, so you got a slideshow now?
Yep.
All right. Okay, well, we'll get into it. I'll apologize ahead of time for my kind of going through this presentation somewhat quickly, but we're going through just talking about the as the chapter says and the unit says, the history, trends, issues, and challenges in plant science. And we're kind of going along with the chapters from the 5th edition. So if you have the 6th edition, it might be a little bit different. Hopefully I'll get it one of these days in the mail. But nonetheless, it should be the same material, just probably in a slightly different format. This is kind of the format we'll be going through for the whole class, kind of following along. I did put slide sheets as well as the kind of PowerPoint presentations on to Canvas, so those should be available to you. If you try to preview it in Canvas, it might not show up correctly, so it's best to download it if you want that. Otherwise, you can always come back to the class recording and look through it that way. I think you should also get a audio transcript through it. That can be helpful for finding particular parts that you need knowledge of. Hint, hint for the quizzes. Not trying to make it too easy on you guys, but All right. So sorry for the funky formatting. Sometimes things get a little funky here in the world of virtual education. But we're going to start off with the history and really talking about the history just first of plants and thinking about the kind of evolution of plants. And you'll notice that I've kind of highlighted the high points. So those are what we're really going to focus on. So the word here, angiosperms, basically saying that these are the most highly evolved group of plants. Angiosperms are the flowering plants. So the plants that actually produce flowers, fruits, seed. Um, Most evolved, I say, just because they actually developed flowers and they co-evolved with insects usually. So typically they have some sort of pollination system. Not all of them. The grasses, for instance, are wind pollinated. More on that later. So I kind of gloss over some of this stuff about, I don't think the people in the book here necessarily are anthropologists, but they give you a little bit of anthropological perspective. They say that modern man, our species, Homo sapiens, appeared about 28,000 years ago. Hey, that's what they say, whatever. Anyway, what I want to just note here is that kind of both the plants and the people, we haven't really changed much biologically since their appearance. So the plants that evolved millions of years ago are pretty much the same as when they evolved. They probably changed somewhat, but there's not enough time to really dramatically change, biologically speaking anyway. So what I want to note here is that, and we mentioned this in the first class period, is that we actually evolved more as hunter-gatherers. So for the thousands of years that Homo sapiens has been on planet Earth, we were hunting and gathering and not actually practicing agriculture. Let's fast forward. They often say 10,000 years ago, but I edit that to say around 14,000 years ago. That's what the modern, I guess, anthropological, archaeological evidence looks at, is when we began the purposeful cultivation of plants. So they say 10 to 14,000 years ago, so I'm going to say around 14,000 years ago. And it didn't just happen overnight. There were small incremental changes in the way that we cultivated plants, but it was believed to have begun in the Middle East and Africa, the Fertile Crescent, Mesopotamia, what they say is modern day Iraq. So the big deal here is that we started to actually first witness changes in plants, probably some natural mutations. We started to save the seed of those plants and replant them. There's no way that that could happen overnight. It had to happen over really thousands of years. So that's the reason why we say 14,000 to 10,000 years ago. And hey, it's still happening today. We're still cultivating and changing plants. So we cultivate plants, we reduce our need to travel, to hunt and gather. And we start to settle down, and we also begin to trade goods. So commerce begins, civilization begins. Just a little bit more here on this cultural revolution, that's what we call it, this change in our culture going from hunter and gatherer to practicing some agriculture. There was a plant scientist from Russia, Nikolai Vavilov. Well, at the time, I guess it was the USSR, but he suggested that there were 8 centers of origin for our food crops. And they're kind of circled here in this image. And this is where those crops first popped up, where we first began to use them for food, most importantly, and then later on, fiber, medicine, but not them just popping up, but them being different from their wild ancestors, actually being cultivated into crops. And so the important thing to note here is that agriculture is popping up all around the world around this same time, same time being that period of 4,000 or 5,000 years. So it doesn't seem like the same time to us, but in the grand scheme of things, it is a very similar time period. Because at this time, agriculture is just starting to be practiced, civilizations are starting to be born, and there isn't yet really trade between these zones. So anyway, he discovered these areas. He was this, I think, a very important plant scientist who established where these crops originated. And then later on, he found that this is also these centers of genetic diversity. And let me just take a look at this image here, which is kind of saying what crops came from. And I've highlighted these areas where those first 8 centers of origin are, and from that they've developed more centers of origin, anthropologists, plant scientists, to see where these crops came from. And that is important to us because where those crops are developed are the areas where basically they have the climate that is best suited for those crops. So in many cases, if we can emulate that climate, then we can produce that crop. And also, that's where the genetic diversity of those crops are stored. So today, plant breeders go to those areas of genetic diversity and try to find unique traits of those crops to kind of breed back into the modern plants. So for instance, let's look at, say, Western and Central Asia, where it is believed some of our tree fruits first originated, like the apple. So there's actually all these neat wild apple trees there of all different kinds of colors. And if you go, breeders are now going back to this area, they're finding these wild apples and maybe taking some of the disease resistance traits and trying to breed them into the modern apples. So anyway, I say all of that because this idea of these areas of genetic diversity is very important for us to be able to continue to breed the crops for the future, make them really more sustainable. All right, so kind of fast forwarding here a little bit. As that trade increases between these different areas of civilization, then there also is developed this idea of the rural and urban interface, which I think is also a big issue today. So the urban citizens, people that live in the city centers, become less aware of how these plants are being used and how important it is that they rely on the rural areas. So there's kind of a rural-urban interface, but also a rural-urban divide. There's a lot of demand in the urban centers, but not as much knowledge of how the supply is produced in the rural areas. And as that demand increases, we also had to change, and kind of in the rural areas, our cultivation methods to try to keep up with the demand. So, of course, early economics here, we're thinking of supply and demand. And think about how that's changed. So, we started with some simple farms implements, horse-drawn plows, for instance, or mule-drawn, however you want to look at that, and how it's developed today into, using more fossil fuel powered machinery. So I think this is an important time to just kind of look at the difference in, we'll say, agronomy instead of agriculture, being the study of field-grown crops, mostly those that are commodified and used for more the industrial purposes, and horticulture, which are those require more intensity, higher, usually higher value crops as well. So really, I think that it's not black or white. Really, it's kind of a gray area where these disciplines overlap. But generally, we're thinking of more extensive, the field-grown crops for agronomy versus horticulture being the more intensive, usually a smaller scale, usually higher inputs, but also higher value. So that's an important thing to somewhat distinguish here and to think about. So agronomy, we think of the subsidized and commodified crops. Horticulture, we think of the more higher value crops that, and really there's more of a variety. So we might think of things like wheat, soy, corn, hay as being more in the agronomy world, and also less people. Actually was able to visit one of the largest farms in the Central Valley of California, over 1 million acres. Boswell Corporation. At that point, it's not even called a farm, it's called a corporation. And they had 10 agronomists working for them, and each agronomist is over 100,000 acres. So it's kind of a totally different. In the world of horticulture, we might think more of a small scale operation, less crops, but more people working on it. You might have 10 people working on 1 acre. So think about that and distinguish between the two. Both extremely important for our economy and for our civilization, but different. All right, let's think about kind of going along with that. We think of the crops as being commodities exchanged for money in a marketplace. And with that commodity comes some classical economics here, the whole idea of supply and demand, with the supply being influenced by the availability of resources, the demand being influenced by the value that the consumers place on that commodity. And it's important also to note here that there is a mismatch often between the dollar value and the actual ecological value. I guess what I would think of more as the true value of the crop. Kind of thinking about what resources are placed on that. So on that end, kind of thinking of the idea of how agriculture and ecology kind of are working together. One of the big, I guess, historical instances that we can look at from that perspective is the Dust Bowl era. And kind of in the late 20s into the 30s, basically we kept plowing the prairie, which the prairie, they say, was one of the most diverse and most important areas for crop production. And today, it's the Midwest. It's where the majority of the commodity crops and agronomy is practiced in the U.S. The bread bowl of the world, we call it. But because we were continually plowing it, trying to meet the demands of the crop, it led to soil erosion, which led eventually to these massive dust storms and that loss of soil, massive loss of soil, from which the Soil Conservation Service was born. And the SCS, the Soil Conservation Service, started as just kind of looking at trying to conserve soil, but they're looking at this kind of research and education of all the factors that go into that. And today it is known as the NRCS, the Natural Resource Conservation Service. And so they look at soil and water and nutrients and the relationship of all of those combined. Very important to just recognize what the NRCS, which is a branch of the USDA, does and the services that they provide to us and potentially to you guys as well. Lots of grant programs out there. They can help out beginning farmers. So keep the NRCS in mind. Just recognize that that came from the Dust Bowl. All right, so a little bit more here on the idea of the economics associated with agriculture, and something that I don't know, I think is kind of weird to me, and it kind of harkens back to that quote from Dwight D. Eisenhower, how it's easy to think about farming when your tractor's a pencil, right? And the farm is miles away. How the policy doesn't necessarily match with the issues, and to me that is reflected in the financial analysis and how we look at the future values relative to current values, and really how there is kind of some conjecture and some gambling, some legal gambling associated with the financial analysis of crops, and that affects the bottom line for producers in many ways. How can you get the money for your crop, basically? And that's especially in the commodity crop world, that is reflected in exchanging of stocks. And I'm not going to get too much into that because there's a whole class devoted to that. And Tom teaches it, so we'll leave that to Tom.
Yes, I do.
However, I do want to point out this idea of sustainability here, though, and just this idea of how can we really sustainably produce crops. And we think of that as being a triple bottom line. Sustainability is more, we're more aware of it now. I think, the Dust Bowl era, we weren't really thinking about it. So I call it the triple bottom line because it's looking at how we're affecting the environment, how we're affecting the economics of it, and the social issues associated with it. And really I guess the guiding principle of sustainability being that we want to be able to produce it without affecting our ability to produce it in the future. So that's a big issue, I think, in plant science and technology. And what we want to look at really is just balancing the energy and resources kind of amongst the ecosystem, or what we'll refer to as the agro ecosystem, the agricultural ecosystem, trying to keep it intact and preserve the ecological relationships that we'll talk about in more detail later on. And the idea here is that we're taking energy to produce a crop. We have to put in these inputs to get an output. And really, we need to balance these inputs and outputs. For everything that you export, you need to import, especially on the nutrient scale. For every time we harvest something, we're taking nutrients away. We got to put those back in there. And that all kind of is related back into this idea of kind of a loop, if you will, and we want to try to close that loop so that we're not losing soil, we're not losing nutrients, we're maintaining this stream of production and income based on that. So from that, we'll take a look at this table here out of the book that is looking at the embedded energy, or emergy. The dollar prices of agricultural commodities, as they say here, appear to be much too cheap when we look at the embedded energy with them. So for embedded energy, what we're thinking of is all the fertilizer, all the gas that we put into, all the fossil fuels into producing the end result. And it doesn't necessarily link up with the actual dollar price. So more on that later when we talk about ecology. Looking at how it's kind of changed historically, what we have in the US as agricultural commodities, the prices tended to actually fall as yields increase. So yields increasing, there was a decline in the per acre income. And that's just related back to that economic idea of supply and demand. As the supply increases and the demand stays the same, then the price is going to go down rather than go up. So something important to look at, especially in the commodity world. It totally affects how we're able to price and continue to practice our agricultural products. And within that enters the idea of the commodity system being subsidized by the federal government. So with the subsidies, basically we're looking at these commodity crops and we're giving extra money to these, often to these very large farms, so that they can continue to practice without being as affected by the futures, the stocks, the economic situation of it. And a result of that is that the number of farms actually end up decreasing as we, kind of focus more on fewer farms but larger farms. And this kind of look at Secretary of Agriculture Earl Butz. He basically said, get big or get out. And I think that's something that we're starting to look at, a trend that we're trying to look at reversing now. Especially today, as we see supply chains being affected, it's better to have more feeders into that supply chain than fewer. Especially when we look at the gaps, the good agricultural practices. Along with that, we have the number of farm workers continuing to decline. And this is kind of an average looking over time, but now we look at about a 1-to-1 ratio, one full-time worker for each farm, or maybe we should say one full-time, actually paid worker for each farm. In some cases, we might have more workers, but only one of them is kind of what we think of more as the agronomist, the person who is making the big decisions, managing the farm, and making most of the money. And that kind of stabilized as we started to enter the 21st century. We also have area of farmland declining as well. And I don't want to say that's necessarily a bad thing, because in some cases it means that we're producing more and more outputs per acreage area of inputs. So that could be good. Either way, as you see here in this figure, farmland is decreasing, and there's an interesting trend here in the US that forest land is increasing. And that's probably correlated in that there's being more farmland abandoned. I would just note here that while woodland might be increasing, that's not always well, it's not necessarily a good thing or a bad thing, really. But if you go out and you look at these areas of woodland and how they've changed, they're not like your native forest land. Often they are full of invasive species because we plowed and disturbed that soil, and then we have kind of junky trash trees, what I call them anyway, coming in and growing in place. They're not really good for timber. They're really not great for habitat either, at least for our native organisms. So we'll save that discussion for another day, though. Let's just take a look here at population and how population affects agriculture production. Of course, it's increasing worldwide and in the US as well. As the population increases, it's mostly happening in the urban areas. So, and also in the relative terms of urban to rural areas. So 60% in 1900 were people living in rural areas. To 2000, century later, 25%. So dramatic decrease in the population of us rural dwellers, right? And a dramatic increase in the population of people in the urban areas. So urban areas are developing, although in some cases we're thinking of it more as the suburban areas, often in coastal areas in the eastern US. Lot sizes changing, lifestyles changing, and also the demands for energy and crops changing too. So is that a good thing? Maybe, maybe not. It just depends on what your perspective is. I think there are opportunities as well as some, I guess, just some downsides. So let's think of an opportunity here in the horticultural realm. Golf. We have any golfers out there? So we say that golf alone is now equivalent to about 2/3 of major crop sales just because of the dollar amount associated with it. We also think of the housing market as being really a big conversion of farmland to, suburban sprawl. And associated with that, though, we also have landscaping. So there's another opportunity for people. All of this kind of goes to look at how there has been a change in the dynamic of supply and demand, which leads to a rising cost of fuel. That fuel, unfortunately, is the same fuel that we use in many cases for our agricultural production. So we have a rising cost of fuel because there's a rising demand and not always a rising supply of it. So we have increased costs both to a producer and consumer kind of across the board. Inflation. All right, so this kind of leads to this graph of these two major trends that are going to affect crop production and the environment, really, the global environment associated, because we have increases in population and energy use. We are, concerned about the issue of overpopulation. Can we continue to support a growing world population? Although some of the, population ecologists believe that it will stabilize around 2050, but how is that going to affect, how we produce crops and how we're able to make the bottom dollar on our crops? So overpopulation is a big issue. I would kind of conjecture here that one of the issues with overpopulation is that it is mostly happening in, or I guess the increases in population are mostly happening in areas that are not developed as much, or that are beginning to be developed. So we don't see it quite as much in the United States as you might see it in like China or India. These are developing nations where they're using a lot of energy. These economies are developing. In some cases, that means that we could have new places to export agricultural commodities. So that's, I guess, a positive to the idea of overpopulation. If you think about just the population of the U.S., about 320 million people, we have plenty of land to sustain us. And that's why we think of the Midwest as the breadbasket of the world, because we're producing a majority of grain crops, really for a lot of them for export. So along with that population increase, we also have energy use increasing. And we say that that is going to be increasing about twice as quickly as the population because of economic development. And we look at how there's a change in how the resources are allocated to the people. So when people become more affluent and they have more resources to going, I guess, really to less people, then they kind of change the way that they consume foods. So one of the things that we look at and population ecologists look at, especially in like China, for instance, is that they might be going more from a vegetarian diet to more of a animal product diet. Can't really criticize them, right? I mean, that's what we did as well. Instead of having meat maybe more as a luxury, it's becoming more of a mainstay of a diet. If we go back in time to when civilizations began to pop up, the agricultural civilizations were kind of based on a fairly simple diet, and often it was kind of more vegetable based. Even the hunters and gatherers got more of their calories kind of on the pounds from fruits and vegetables rather than from animal products. So the more money that people have in these growing populations and economies, the more they want to eat the good stuff, meats. So that changes the way that we use the land. So here's a graph looking at this shift in the food consumption patterns and kind of how it's associated with our food producing capabilities. And again, I think it's important to note that we've got a lot of land per people, per capita. So we can kind of get away with that more than they can in other parts of the world. Another thing to look at here is how we changed genetically. So the crops themselves, we had to figure out ways to get more off of less land. And we did that through really through plant breeding, through developing new cultivated varieties. So cultivar is a cultivated variety, and it is basically developing more high yielding varieties, often of both plant and animal crops. We think of cultivars really as being in the plant world, but hey, there are varieties of different animals too. So, as we all know. All right, let's look at something I already mentioned here. China being a major challenge to the world's food supply, as it's now over 20% of the world population, but they have less than 7% of the world's cropland. So in 1950, they had about 0.2 hectares, which a hectare is something like 2.2 acres per person in 1950, and now it's about 0.08 of an acre per person. So they don't have the land that they need, which is why it's such an important source of exports for us. It's a major customer of us for the export of agricultural commodities, especially things like soybeans. So we talked about it quite a bit last year. I think it was more of a modern topic then, but how the tariffs and trade with China, the trade wars with China, were affecting the global economics, agricultural economics. So an interesting thing to look at and important to keep up with. You might remember from last week on Wednesday, we were talking from that VDAX brochure that China is the largest importer of crops from Virginia. I wonder how that's changed since the trade wars. Anyway, let's look at other issues with kind of the global trends. We have a globalized economy, and because of that, we depend on exchange from around the world. There's some consequences to that, and part of that might be the whole idea of climate change, which personally I think is a big deal in terms of future crop production. It's a big challenge for us in the plant science world, and of course it's changed. We don't really know what it's going to do, what it means for crop production, and we'll stay out of the kind of political realm here, but whatever you believe in terms of climate change, I think you have to recognize that it is real, it is happening. I'll leave it up to you whether you think it's caused by humans or not. There definitely are natural, changes in the climate just due to the cycles. But nonetheless, it's important to recognize that there are some connections between the rise in atmospheric carbon dioxide to rising temperatures and other weather changes. They used to call it global warming, but now we know that it's not necessarily global warming. There's all kinds of different things that happen associated with it. Whether it be extended periods of drought, for instance, or super hurricanes, whatever. However you look at it, it's something that we have to think about how we can contend with it. In some cases, it might be good. It might mean that we can produce new crops in our hardiness zones. We actually used to be a USDA zone 6. They changed it to a 6B, which is a average change of 5 degrees in temperature. I usually actually suggest that we plant things based on a more of a zone 5, depending on what the microclimate is. And the reason I say that is because, yeah, it has warmed up. We tend to have some mild winters these days. The first frost date has, at least from my records, has often kind of been pushed back. We used to say it was October 10th for where we are in Washington County, Virginia. We had years where it was in November. Either way, we also have even colder winters some years. So we also had a winter a few years back that we recorded 16 below zero, which is unheard of in our zone. Anyway, not going to dwell on that too much. Just want to throw out the importance of this challenge and issue of climate change for our global food production. Here's another thing to look at, and this was also a big issue last year. Remember when the Amazon was on fire? There's a demand for food and fuel increasing that is leading to deforestation in many tropical countries, in this case in Brazil. And it's also important to note that those forest fires started were actually, and you can kind of see it just from this aerial imagery, that it's not actually just a natural forest fire occurring. It was starting from land clearing. We're deforesting so that we can practice agriculture on these areas. And the issue with that is that these tropical rainforests, they're really not great cropland. The topsoils there are very thin. It's a very complex ecosystem, and it is not easily restored back to forest. We have the benefit here, if we clear land in the eastern US, it's going to go back to forest, and it's going to be somewhat similar to what was there before. In the tropics, though, it takes a very long time for it to restore to its kind of natural ecosystem. We think of tropical forests as being a major sink of carbon that we're generating through all of these different processes. And in this case, last year, it was becoming more of a source of carbon as those forests were burning. All right, so anyway, we're looking now at a globalized economy, and there's lots of side effects of this globalization of trade, and that includes the introduction of new pests and diseases. And we'll talk about that in more detail later on, but something to think about, food for thought, the emerald ash borer came from China, and right now it's started in the Great Lakes region. Now it's devastating ash trees around the country. They're almost all gone in our part of Virginia, or on their way out. And that would actually just happen in the past few years. The emerald ash borer wasn't here, a decade ago. Here's another potential side effect, the idea of bioterrorism. And although I don't think there have been very many cases of this out there, you might wonder that some of it could be. And actually, maybe there's more than we know. Did anybody get any unidentified packets of seed in the mail this year? Could that be bioterrorism? Be a good news article to discuss. It was coming from China, and many of those seed packets that were turned into VDACs anyway, they analyzed the seeds, turned out to be invasive plants. So that's a concept there of bioterrorism. There's a whole lot of other potential bioterrorism issues there. Something to think about. I think a huge issue is just costs. So we have to find ways to meet our need for agricultural products without negatively affecting the environment. And that's due somewhat to costs. The costs of labor, for instance, are increasing, yet the costs of the products are not. So how do you match that? How do you get those together? So one thing that we look at, kind of getting more towards some of the answers here, potentially genetic engineering. So they often call it GMO, genetically modified organisms. I'm just going to go ahead and say right now, let's try not to use that term GMO. Let's use genetic engineering instead. Because really, if you think about it, all of the plants that we have bred, we have technically genetically modified. Genetic engineering really, though, is what's occurring in a lab where we're inserting genes from one crop into another, or in some cases from a totally different organism. So we'll save the debate there on genetic engineering and more explanation of that for another day. Some other issues here, another maybe potential answer, at least the book suggests, is maybe organic crop production. I would argue that organic crop production is neither good nor bad. It just all depends on what your perspective is on it. And I think there are lots of good things about it, but also there are some issues. For instance, if we look at nutrient exchange, in some cases, organic farmers are putting a whole lot more nitrogen on a crop than there needs to be. And there's even more nitrogen runoff from organic farms than there is from a conventional farm. So again, another thing to debate about for another day. We're getting close to the end. I'm not sorry for taking up a little bit of extra time here, but another issue is not just creating the food, but it's getting that food to the people. So there are issues, kind of more social issues here. We still have malnutrition and starvation even in the US today. So I'm just going to throw that out there. And I'm going to try this note, this final slide here, looking at the genetic engineering. You really can't buy genetically engineered crops in the produce section at Food City or Walmart or wherever you're shopping for your produce. What we see there, there's just not genetic engineering taking place in those horticultural crops. We see them in the commodified crops. And most of that genetic engineering is to allow herbicides to be sprayed on them in the case of the Roundup Ready crops. Or there's also been some that have been genetically engineered to synthesize a natural pesticide, a bacteria, Bacillus thuringiensis, so that the pest feeds on it and it dies. And finally, there's also some genetic engineering to have rice to produce beta carotene, which they believe has saved the eyesight of children where vitamin A deficiency has occurred. So some good stuff there for genetic engineering. All right, so sorry I just talked at you guys for the whole period here, and we're kind of, I guess, beyond our allotted time, so we'll save questions for Wednesday and go ahead and sign off.